Hi guys, Audrey here. So today we're going to solve this matrix equation. A plus B inverse times AB times C transpose D plus X equals B, and we want to solve for X. So we're assuming that all of these are square n by n matrices, says A, B, C, and D, but we're also assuming this about X, and that all the necessary products are defined. Also that they're all invertible, so I can take inverses, I can multiply the things together if I need to. It's all gonna work out. Okay, so what I see here, we're just going to go about this problem in one way, but as usual, there are probably multiple ways that we could approach the problem. And the first thing I see is that my C transpose D plus X is inside of these parentheses here. So I need to move these two factors to the other side of the equation. So we know when we have multiplication, the way we move things to the other side is by multiplying by the inverse. So I'm going to start by multiplying by A plus B inverse inverse on both sides. That A plus B inverse inverse has to stay on the left because it's on the left side of the equation. So that means over here, I've made I, because a matrix times its inverse is just I, and then I have A, and then I have B. We'll put it in parentheses because that's how it is. And then I'll have C transpose D plus X is equal to A plus B inverse times B. Now be careful, this is not equal to B times A plus B inverse. So don't do that. Now, multiplication by I doesn't change anything, so we can just get rid of that I there. And now we want to move this AB to the other side. The AB is also multiplied by something that is also multiplied by the factor that has X in it. So in order to move it to the other side, we would want to divide. We can't divide, so we multiply by the inverse. And that inverse, in the same way, has to be on the left side over here because I'm tacking it on the left edge. It has to stay on the left side. So we've made I again. C transpose D plus X is equal to AB inverse times A plus B inverse times B. Now that I doesn't have to be there. I'm going to get rid of it in the next step though. So this would become C transpose D plus X. It's likely multiplied by 1. And I'm going to use my matrix operations properties to distribute that inverse there. So I'll have B inverse A inverse times A plus B inverse B. And I did that for a very specific reason. So here we were using AB is equal to B inverse A inverse. And I just want to point out that there's a B inverse here and there's a B here, but I cannot make I because there are other matrices stuck in the middle of them. So I can only make I if they are touching, if one is right next to the other. I cannot make I. And so another thing that people like to do would be to make I right here. I also cannot make I here because that A is inside parentheses with an inverse on the outside. So it's not just multiplied by A, it's multiplied by A plus B inverse. So I can't make I from that because they're not actually being multiplied together. And I can't make I from the B's because there's all of those other things in the middle. So I can't actually make any I's here. All right, last step towards isolating X. X is now being added to C transpose D. So to move C transpose D to the other side, I just subtract. So my final answer here is X is equal to B inverse A plus B inverse times B minus C transpose D, and that is my final answer. That's all. Bye, guys.